Hi, Algebra 2. Tonight's topic, learning targets, is I can solve a linear quadratic system algebraically, and I can solve a quadratic system algebraically. The third one, you're also going to learn about how to solve when there's a circle. And our first question on our notes has, how do you solve a system of nonlinear equations algebraically? And the answer is solve using substitution or elimination. So the difference when it comes to solving is you can, again, use graphing or solve algebraically using substitution or elimination. So our first example here is a circle. See how it has x squared and y squared, so it's a circle. And then we have a line. We have no x and y are not squared. So we have a circle and a line, and they want us to solve where the system intersects. So as we know from our last class, a circle and a line could intersect in two places, or in one place, or not at all. So to me, in this equation, substitution looks easier to do than elimination. We already have x isolated here, so I can substitute in for x to solve for y. So again, remembering substitution, this part here is going to substitute in for that x in that equation. So when we go to start here, this x is going in for there, so the x is equal to 3y minus 5. So in place of that x, we're going to put 3y minus 5. And since this x is squared, we're going to square 3y minus 5. Then we're going to add y squared and equal to 25. So we have combined these two equations. We've placed what we saw x was solved for and placed it into the first equation. Now all we do is solve for y. And I'm going to FOIL out this binomial. Okay, that looks like a t instead of a plus. Let me fix that. So 3y minus 5 squared, remember, is 3y minus 5 times 3y minus 5. So when I FOIL that, or you can use the box method, my first term is 9y squared. My outside terms are minus 15y. My inside is another minus 15y. And then my last terms would be negative 5 times negative 5, so that would be positive 25. Okay. So now we have a quadratic. So remember, anytime we have a quadratic, we're going to set the whole thing equal to 0. So most of our items are on this side. The only thing I need to move to the left side is this 25. But before we do that, let's combine some like terms. So we can see that 9y squared is a like term to y squared, and negative 15y and negative 15y are alike. So if you add 9y squared plus 1y squared, that would be 10y squared. And then if you add minus 15y and add another minus 15y, we have minus 30y. Then we have plus 25 and equal to 25. So again, with the quadratic, we want to set this equal to 0. So I have to do that, since this is on this side of the equation, to move it on this side, I have to subtract 25 from this side to make that 0. Let's go ahead and move that down, make a little more room. And subtract. Anytime you do one thing to one side of the equation, you must do it to the other. So that would make 25 minus 25 be 0, and you'll be left on this side with 10y squared minus 30. Y, minus 30y. Now we're going to solve for y. So here they have a common factor of 10y. So I'm going to factor that out, and we'll have y minus 3 left. Now we're going to use the zero product property to solve for y. So we have 10y equals 0. So to isolate y, we divide 10 by both sides. So that would make this y, and 0 divided by 10 is 0. Our second factor will set equal to 0. Y minus 3 equals 0. And so I'll add 3 to both sides and get y equals 3. So for this solution, I have two y's. So it looks like we have two solutions for this circle and this line going through twice. So we have the y values. Now we need to substitute in to the line equation to find the x. So let's go ahead and change colors. And our equation is x equals 3y minus 5. So the first time I'm going to substitute in 0 for y. So 3 times 0 is 0, and 0 minus 5 would be negative 5. So our first point is negative 5, 0. Our second point, we're going to substitute 3 in for y. So we have 3 times 3 minus 5. So we have 9 minus 5, which would be 4. So our second point is when x is 4 and y is 3. So those are our two solutions, negative 5, 0 and 4, 3. Let's look how that would be on a graph. Let's go ahead and graph that and confirm our answer. So we have a circle, x squared plus y squared equals 25, and our center would be 0, 0, since h and k is 0, and our radius would be 5, because the radius squared is 25, and I would take the square root of 25 to find the radius, so our radius is 5. So we have a circle with a center of 0, 0, and a radius of 5. Go ahead and pause the video and graph that. Okay, so your circle should look like mine, where the center of the circle is at 0, 0, and your radius is 5 units. Okay, now go ahead and pause the video and graph your line. Okay, when you graph the line, you first had to place it in y-intercept form, unless you were using another method that you might have learned in Algebra 1. But if this equation was set up as x equals 3y minus 5, so I went ahead and solved for y, and first I added 5 to both sides, so then I had x plus 5, and then that was equal to 3y. So then I had to divide 3 by everything to isolate the y. So 5 is divided by 3 and x divided by 3. And then we have y equals, and then to help us graph our line, I changed it to 1/3 for the slope, plus our y-intercept would be 5/3. So then when I graphed it, we're going to estimate 5/3 here, so that's 1, and that's about 2/3 of the way. So that's my y-intercept, and then my slope would be up 1 and run to 3. So 1/3. So then 1, 1, 2, 3. Okay, and then also going back. Down 1 and to the left 3. Okay. So once you graph your line, you can now see your points. Our solution again with our systems is where they intersect. So our circle and our line intersect here, and that does confirm what we found with the substitution. And that was at 4, 3, and that is that point of 4, 3. So we confirmed that answer. And our second one of negative 5, 0, we also confirm that. So both methods shows that the answer to the solving the system of this equation is 4, 3, and negative 5, 0. All right, I want you to go ahead and try some. Go ahead and try 1, 2, and 3 and bring it back. Okay, great. When we have number 1, I decided to use the same method as the last time and solve for x and then use substitution to replace it. So when I solved for x, I got, in this equation, I got x equals negative 2y plus 3. Then I took negative 2y plus 3 and substituted for this x. So we have negative 2y plus 3 squared plus y squared equals 9. When I FOIL that out, I end up with 4y squared minus 6y plus 9 plus y squared equals 9. Then when we set the quadratic equal to 0, you end up with 5y squared minus 12y equals 0. Then we factor to solve for y, and the greatest common factor is y, so we factor that out. Now we have two factors that will set equal to 0 to solve for y, and y is equal to 0, and then 5y minus 12 is equal to 0. So we end up solving for this y would be 12/5. Then we have to substitute them back in to solve for x. So solving for x when y is 0, you get x is 3. So the point of the solution for this one would be 3, 0. When you substitute in 12/5 into the equation to get x, you end up with negative 9/5. So we have 2 points here, 3, 0, and negative 9/5, 12/5 as your points of intersections. You want to make sure you check. The nice thing about solving these equations is you will know by the end if it's correct. So you check both points and show that they're correct. Okay, for number 2, I decided to use elimination to solve number 2. This equation sets up really well for elimination since you can add them and it would eliminate already the x squared term. So I went ahead and just started with elimination and added the two equations. So y plus y is 2y, and then x squared minus x squared would be 0, and 1 plus 3 would be 4. So you're left with 2y equals 4, and then to solve for y, you divide 2 to everything, and you're left with y equals 2. Then you have to solve for x. So I took 2 and substituted into the first equation. So 2 equals x squared plus 1. And then I solved for x squared by subtracting 1 from both sides. And then I got x squared equals 1. And then to isolate x, we'd have to take the square root of both sides. So that's what I did here in this step. So x would equal plus or minus 1. So then we have 2 points, negative 1, 2, and 1, 2. And then you would check your answer. For 3, I used substitution and found